The topic for Lesson 5.2 is Inequalities and Triangles. We will look at how to recognize and apply properties of inequalities to the measures of angles of a triangle, and to recognize and apply properties of inequalities to the relationships between angles and the sides of a triangle. How can you tell which corner is bigger? Sam is delivering 2 potted trees to be used on a patio. The instructions say for the trees to be placed in the 2 largest corners of the patio. All Sam has is a diagram of the triangular patio that shows the measurements of 45 feet, 48 feet, and 51 feet. Sam can find the largest corner because the measures of the angles of the triangle are related to the sides opposite them. So let's go ahead and answer that question. We want the largest side is 51, so the largest angle is going to be opposite the 51. The next largest side is 48, so the next largest angle will be opposite that. So those are 2 angles that he'd want to put his pots at. We're going to back up a second and define inequality. For any real numbers, a and b, a is greater than b if and only if there is a positive number c such that a equals b plus c. So, for example, if 6 equals 4 plus 2, 6 is greater than 4, and it's also greater than 2. The properties we had for inequalities of real numbers, we had a comparison property, so either a is less than b, equal to b, or greater than b. The transitive property holds, so if a is less than b and b is less than c, then a must be less than c. And if a is greater than b and b is greater than c, then it follows that a must be greater than c. The addition and subtraction properties work. If a is greater than b, we can add c to both sides or subtract c from both sides, and it's still true, either greater than or less than. And multiplication and division properties, the only thing we have to watch out for is if it's a positive, all is well. Inequality stays the same. Positive, all is well. If we divide by a negative, then we have to reverse our inequality. Example 1, they ask us to determine which angle has the greatest measure. Well, 4 and 5 are both 90. I don't know exactly what 2 or 3 is, but I can see that 1 is an exterior angle, so 1 must be equal to a measure of angle 3 plus the measure of angle 4. So 1 is going to be our greatest angle in that diagram, also because it's the only obtuse, goes to reason. So our answer would be angle 1. Example 1 leads us into Theorem 5.8, which is the exterior angle inequality theorem. If an angle is an exterior angle of a triangle, then its measure is greater than the measure of either of its corresponding remote interior angles. So in this example, measure of angle 4 is greater than both the measure of angle 1 and 2. And I thought their tip there was worth mentioning. We have 2 symbols that look quite similar, so we need to watch our penmanship. The symbol for an angle measure looks similar to the less than symbol when handwritten, so be careful to write them carefully where both are used. For example 2a, we need to pay attention to the directions. They say, use the exterior angle inequality theorem to list all angles whose measures are less than angle 14. So I'm looking for exterior angles. Okay, 14 is an exterior, so remote interior to 14 I can see in that little triangle are 4 and 11. And looking at the next biggest triangle there, I could see 2 and then 3 and 4. So if it's bigger than 3 and 4, it's definitely bigger than 3. Now, angle 11 and angle 9 are vertical angles, so we can get angle 9. 9 is the exterior angle to this little triangle, so then 9 must be bigger than 6. So if 14 is bigger than 9, it must be bigger than 6, and 7 is also a remote interior angle to 9. Same diagram for example 2b. This time they ask us to use the exterior angle inequality theorem to list all angles whose measures are greater than the measure of angle 5. So I'm looking for exterior angles. So 17 is exterior to that little triangle. Ten is an exterior to that same triangle down there. Now 16 is exterior to this triangle, so 16 is greater than 10, so it must be greater than 5 also. 10 and 12 are vertical angles. If we have 10, we get 12. And then if we have 12, we can see that 15 is an exterior angle to this triangle here that has 12 in it, so then we can get 15 also. If one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. That's theorem 5.9. For example 3a, they ask us to determine the relationship between the measures of angles RSU and SUR. Looking at the side opposite, the first angle we have 5.3 and the second angle we have 5.2. So 5.3 is bigger, so that means the measure of angle RSU must be bigger than the measure of angle SUR. Okay, next they ask us to determine the relationship between the measures of angles TSV and STV. So opposite the first angle I have 4.4, opposite the second angle I have 4.8, so the first one is smaller this time. So we have the measure of angle TSV is less than the measure of angle STV. This one gets more interesting. They want us to determine the relationship between the measures of angles RSV and RUV. In part A, we already said that RSU is bigger than SUR because 5.3 is bigger than 5.2. And then we can see angle USV is bigger than SUV because 5.1 is definitely bigger than 4.8. So if we add the two bigger parts together, it's obviously going to be bigger than adding the two smaller parts together. So just rewriting those as their added angles, we'd have the measure of angle RSV is greater than the measure of angle RUV. Ebony is following directions for folding a handkerchief to make a bandana for her hair. After she folds the handkerchief in half, the directions tell her to tie the two smaller angles of the triangle under her hair. If she folds the handkerchief with the dimensions shown, which end should she tie? Well, we have an isosceles triangle, so the biggest angle has to be opposite the biggest side, so that would be angle X. So that means angle Y and angle Z are the two smaller angles. So Ebony should tie the ends marked Y and Z. Because theorem 5.10 says if one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. So bringing it all back together, the largest angle in a triangle is opposite the longest side, and the smallest angle is opposite the shortest side.